Hi everyone. I wanted to go over a few examples from the two-step equations homework, and I'm going to jump down to number 7 to start because it's a good example of how you think you might have to do one thing but you actually have to do the other. Now we see division and we see addition here, so we'd probably think we need to undo that addition first, but that's not correct because fraction bars are kind of like grouping symbols. The grouping here is implied, meaning it's not written in, but we could write it in there because when v had 9 added to it, it was divided by 3 after that. So in this case, we actually have to work backwards by undoing the dividing by 3. We undo that first. So we multiply by 3 on both sides. That would cancel. We'd be left with v plus 9 equals 24. And now we would subtract 9, since subtraction is the opposite of addition. Our plus 9 minus 9 cancel, and we're left with v equals 24 minus 9 is 15. And very important, we check. Take the time to check your work. Take the time to plug in your answer into the original equation. I'm going to erase all this. Plug in your answer of 15 into the original equation and see if following the order of operations will get you equality. So 15 plus 9, that's 24 divided by 3 equals 8. 24 divided by 3, well, that's 8. 8 equals 8. So when I plug in 15 for my variable v and then I evaluate, I get 8. 8 equals 8. I know I did this right. Next example I'd like to go over is number 12. Number 12. Again, we have a grouping symbol here. And because of that, we have to undo this multiplication first. Even though there's an addition sign, because it's in the parentheses, we know with the order of operations, if we're solving backwards. So whatever's in that parentheses, we're going to do it last. So this negative 12 is multiplying the parentheses. Our first operation here to undo is multiplication. So we would divide by negative 12. And I'm going to draw my little line to keep things kind of straight here. Keep my balance. Divide by negative 12. 144 divided by negative 12 is negative 12. My negative 12 and my negative 12 cancel, so I'm left with x plus 5. If I undo the plus 5, I subtract 5. Subtract 5 from both sides. It's hard writing with the mouse, in case you're laughing at my writing. I'm left with negative 17 equals x. And if I plug that into my equation, negative 17, I get negative 17 plus 5. That's negative 12. And then negative 12 times negative 12 is positive 144. All right, last example I wanted to go over was 14. Now this one gets kind of confusing because right now you're subtracting 6v. So there's two ways you could do it. One of them would be to add 6v to both sides of the equal sign. You can definitely do that. And you'd be left with 10 equals negative 104 plus 6v. You can do that, but since I didn't discuss moving variables on either side of the equal sign, I'll just show you the way that we did discuss. Instead of looking at this as 10 minus 6v, I would change it to 10 plus negative 6v, because we know that adding a negative is the same as subtracting a positive. And that would be equal to negative 104. I haven't changed any values here right now. All I've done is rewritten subtraction as adding the opposite, which you've had on quiz questions, practice, assignments, your last test. Now, I can undo my operations. Negative 6 is multiplying v, and 10 is added to that variable. So I can subtract 10 from both sides, and I'd be left with negative 6. Oops, I'll do this in blue. It helps me keep my operations straight when I change the colors. Helps me keep operations and then my new equation straight. Negative 104 minus 10 is negative 114. So now, if I divide by negative 6, I'm left with v equals, well, a negative divided by a negative gives me a positive. Positive 19. And if I put that back into my equation, 6 times positive 19 is positive 114. 10 minus positive 114 would give me negative 114. So those are some things to look for. The fraction bars being grouping signs, and what can I do if I have a negative variable.